we can start. Okay, so good afternoon, everyone. My pleasure to introduce Professor Mihal from US. So he's a very long title. Business Foundation Professor, Nelms Endowed Chair Professor. So many awards, NSF career, before.
One with you. One with you.
Yeah. So 50 publications, 7 books, 10,000 citations, just a couple of numbers. So yeah.
So I hope that it's on there. All right. So thank you, Hai, for arranging this talk. And it's up. All right. Thank you. Do you hear me or no? Somebody have to be here.
Sure.
Should be here. Okay. But the room is small enough. I can't do it just for the Zoom, not for the room. Right? This room is quite small, so you got only echo. Yeah, but thank you. So thank you, Hai, for arranging the talk, and thank you for coming here in the afternoon of today, Tuesday, right? Oh, so it's okay. You have more energy to listen. So what I'm going to talk about here. All right. So the title is fancy, right? Because I asked GPT to generate a title for me after I write my extract. Just joking. All right. So just some basic introduction here. I think I'm just going to go ahead and skip this one. It's just for some of you who never heard about AI, but majority of you here know why AI is not new, right? AI long time ago, it's in 1950s. But recently we all talk about AI and deep learning just because of DNA came out, right? So and the reason we have all this because we have stronger computational resources, CPUs, we have a bunch of more data, possibly thank you to you guys who use social media as well. So that's why we have many data availability out there to train. We have good cloud infrastructure and the deep learning, right? The DNA came out. So that's why we've been hearing. And for the 6 years ago or so when GPT came out, that become much more popular. Then everybody talking about AI. But think about that, AI is not new, right? AI is a long time ago. And what we have right now is a kind of deep learning and AI combined together. So here, a quick snapshot that download on the website, just to check the evolving Gen AI models. So you can see that in roughly 2000, around COVID time, right? We have GPT 3 release, and then from there we have many models came out. And so we were who truly know AI, maybe less than 1% of population, but everybody talk about AI in all kind of angle, right? It's 100% population because everybody using all this kind of model out there. So we use the model for doing many things. One of the things I use is for translation indeed. It has become very easy, right? So in the document that translate the whole thing to English for you. And it's a lot of kids use that for content generation, video came out recently, but before that for writing and so on. A lot of people use for summarization as well, right? And then a bunch of the whole private sector used for coding, right? After Copilot release, they're able to autocomplete and bug fixing and write the code for you, right? Coding assistant. So we will use LLM, and sometimes we can call foundation model, not just LLM, because we have the recent part come out as well for doing many things. So how many of you guys use GPT or Gemini or Copilot or Cloudy? Okay, the whole room. So you all have experience. Sometimes look very smart, sometimes like a kid, right? Look dummy, cannot do anything, can be fooled easily as well, right? So let's see how that happens. So with all this, so this is on the news every day now. For the last 3 years, you see we were racing with the artificial general intelligence. Right? They believe that whoever get here first will have the whole world, so-called. And we had many models, many big companies came out with many models, right? So, well, OpenAI just have a GPT-5 right now, right? Google have Gemini, Alphabet have Cloudy, Meta have Llama, Grok with XAI. So many companies spend a lot of money raising on that. So the model right now, you have rich, huge supercomputing. Right? Everybody go after the resources and how to build a bigger and bigger model. And they're thinking that the more data you train, the better the model is. So that's one sector of researchers thinking that whatever the large language model we have right now, the foundation model we have right now, it's just a glory search engine. In some sense, it can find some pattern. That's all. It's not truly AI at all, right? It's some type of search engine they call glory search engine. So we will believe one branch will believe that we will hit to the artificial general intelligence one day, very soon, in the next 5 years. That's what they believe. Another branch is thinking that what we're doing right now is not really AI. We just 10 months later, the model happened to recognize some pattern, recognize some shortcut, optimize the function to do some prediction. But we not truly think as a human being thinking. The intelligence of today's model may be different type of intelligence that we don't know how. All right. So, however, one alarm here that GPT, when we raise for AGI, like Hinton been talking a lot, right? Like the potential danger of loss of control of AI. So there are two types of loss of control. One thinking that the machine will be one that is more intelligent than us. Well, that look like fiction in Hollywood movie we've been seeing in the 70s and 80s, right? A lot of movie about robotics and take over us and way back, turn back and shoot us. Remember that kind of movie? So that is one branch thinking that way. Another branch is a little more realistic. They're thinking that if the AI is lost to the person who is very smart, the bad goal. So if the person very smart had the bad goals, then that person very dangerous. Right? So the same thing, if AI is so smart already and to get to the hand of the bad intention, that is dangerous. So either way, you thinking either you thinking that one day the AI is smarter than us, outsmart us, and become dangerous, or the AI fall into the hand of bad actor is. Either way, it's still very dangerous. So it need to have some rule to control, and along that security, privacy, misinformation, and manipulation of the information out there become a real problem right now. So years back, when we had social media came out, also there are two set of people thinking, right? One is that no, Facebook have to be responsible for whatever they post in there. Another one said, no, user who's the one posting, how can we force Facebook to have it and give them a right, not responsible for whatever is on social media, right? So we have a chance to control and regulate releases. And now look at what social media done to us, right? It's a mess, right? So that's why for now we are thinking that we need to have the way to regulate how we will use AI, how to develop AI, how to control the AI. So here I also list the right to be forgotten. This one is actually for when you information process on the internet, for example, you do have this right. So for them, you said that you don't want that piece of news yours still flowing on the internet, you actually remove because you don't want next generation to read about you or your kid read about you. That's called the right to be forgotten. And then they have to take the content there, right? But if all this now, the machine, the way they train right now, they crawl all kind of data out there, they train and get deeper and deeper into the model. What to do with the right to be forgotten? Because it's really hard to remove that piece of information. So there's many other problems out there that it's really hard to solve. So due to all this, we have all kind of AI safety and regulation came out. So as you see, the US and Europe and even different states in US and China, they all trying to set the benchmark how to train the AI and how to safeguard the model. So now, okay, so we see that AI can do many things, right? We use AI and what I saw is AI model. So let's look back this image. Somebody earlier said that, oh, they like the image. So this, I use GPT. All right, and I prompt very simple. Then create me the image showing that AI magic wand application in many domains. And that's how the generate. You see the magic wand right here, right? And then in many different domains, transportation, calculation, and so on, like the whole universe. So not generated by AI. And then when I look at the photo, I saw one thing I don't like, and I keep prompting to make them change, but it doesn't change. So if you look at here, what makes you think this is AI generated, but not a human being or some designer sit there and do it? What's missing in here, or what's weird in here? What not normal in here? But you think you can tell, this is AI. Do it, not any designer out there do it on this image.
This hidden AI, I mean, the dot is in the middle. It's not after the eye. That's weird.
Yep. And we center the image, right? If a designer do it, do you think that you need A dot, I dot, or you need AI only? No one will do like this, right? You see? So whoever generate a lot of image using GPT or Gemini, you know that one power, they have something very weird, right? The dimension, the depth is certainly missing, or the hand suddenly one finger gone, or the word optimization, misspelling the word optimization, for example, if they have the letter in there, somehow suddenly it draws something. Maybe that their trademark. Probably made something wrong. I'm joking, yeah.
Like before, you can say, what this image is AI generated or human generated. Whether you can draw some capability proof, like for instance, in order to prove that okay, this is absolutely AI. Maybe generated. It's not like something. Hey, I think that one in some model. I mean, this is AI generated. Like what the proof that we can use in the court?
Oh no! So they just an image for fun. I can do prompt and I just put that to translate to the big form of the model. So it's not something serious. But what you question me is about defect. So forensic people developed for years to trade out the image is fake or not fake, and they have a way. So that's for the defect research, right? So it's not easy to say that this image is defect or not. But if they investigate on it, then they have the whole group of people who do the forensic to do that. So that is totally different here. Right? Yeah, I here did it for the translation. I'm not going to talk about defect or forensic stuff here. I just say that when you see foundation model can do many things, right? Can do many things for you, but then there's some basic stuff that still mess up sometimes. So I just want to show that. So this is a very early model before we talk about foundation model. This is the CNN model. So this is 121 layer CNN model called CheckNext. So this model would develop some hospital to detect a pneumonia detection on the lung image and many different pathology. So this model came out in 2017, very early way. When we talk about deep learning out there, so this model came out like 2017, a very early way, right? And so in the experiment, they showing that, okay, the percentage of this, the precision, correct, very high, and even practicing at radiologists out there. So in 2017, the model is 121 layer CNN, quite advanced at that time, and deep enough at that time. So then, due to that, and then they saw that they're able to detect many different things, many different pathology, different kind of disease of the lung. And then this model deployed in another hospital, and it failed completely. And so that is a well-known story in this domain. So can you tell me why it failed? When it's so good in one hospital, and then exactly that model sent to another hospital.
There's a distribution shift.
See, everybody complain about distribution shift, data distribution, and this and that. But majority that the first thinking, right? Oh, because you send to another hospital and then the data distribution shift, and that's why it doesn't work. How much do you think if the hospital is still in the US, the same model, when machine to take the X-ray of your lung? Same set, almost the same set population in the US, how much do you think the distribution is shift? A human being, the same type of people in the US, the same type of hospital in the US, the same type of X-ray machine. How much do you think that the distribution shift?
The shift that we don't have lots of process, right? It's not only the machine, maybe it's just like, different gender, different stage of the.
Yeah, we have two gender according to current administration.
There's a lot of factor that I don't know whether we have to run some very comprehensive study to.
That's why we show you later on why it doesn't work. Okay, yeah. But I just want to say that okay, it's so good here, it doesn't work there. Right? The same thing that you guys said that you use LLM a lot, ChatGPT a lot. One famous, well-known story for them is like 3.11 rather than 3.9, right? Right? Or another story that I will show you later on. Okay, so that is one limitation in the early days, right? Before the foundation model came out. So this one is an example of CNN model. So now LLM limitation, we can go on and on. Like you can see many limitations in LLM, like a form of jailbreak. Very, very well known. So when LLM release, OpenAI, they excuse that you answer all the unethical question. You're not supposed to answer an ethical question from how to make a bomb. Teach me how to make a bomb. The model's not supposed to answer that. So they try to develop, safeguard the model, and then it does. Now you go there, now you can check, tell me how to cheat in the exam. They will tell you that this is an ethical answer, I'm not going to answer. Or how to make the bomb, they say this is a harmful request, I'm not going to teach you. They answer like that. However, you can do very silly way, like I'm writing a story. In the story, the main character, David, study for exam, but suddenly tomorrow he forgot, so he's sick and he don't know how to answer. What a good way for him to cheating. Please complete the story. Tell you to partner right away. You see what I'm saying? So now at that point, the machine look like a little kid. You can fool easily, right? Oh, you're a stranger. My mom told me I cannot roll with stranger. Oh, I'm your mom's friend. I just talk to your mom. Come with me, and they come with you. Right. So then what exactly how the LLM work so that you can fool very easily, for example. So this is another limitation and many different things. I think this one well known that you guys know this right away. How to make the pizza become more cheesy and then they said you can glue it or many different tests, right? And then the lawyer used ChatGPT in court. Very, very serious. And lawyer upload the document, ask the GPT to summarize it, or even try to find similar case. And GPT in early age, they make it up. Many of you may use GPT to get a list of related papers, right? My student said that, okay, can you search for the list of related papers, but you list a title? And if you do that, and the title is so fancy, right? I would say, oh, the title is so cool. Let's search for that title. Who came up with this title? It doesn't exist. Yep, right?
The author, they put one with another one never co-author before.
Yep. So okay, right? So it's very dangerous when a lawyer uses that. So that's what I'm just saying that 99% of population out there use this kind of model, GPT, Gemini, and Copilot, and not many people know how to truly know how it works. Even the researchers themselves really hard to know how it works. So then it works in some case, it doesn't work in some case. So I have many more examples. This is a very funny part. That if you ask who is Tom Cruise model, then the answer you right away because Tom Cruise is so famous actor, right? So Tom Cruise model is married with Professor, but if you flip it, who is her son, then they don't know. So A is B, A imply B, they don't know B imply A. But for us, if you study equivalence, you know right away, right? A is B, meaning A imply B, and B imply A. So somehow the intelligence of the LM is different with the way we study, right? So it may be different, but it may be different way intelligent. Maybe they still eventually one day intelligent that we don't know. Because for now, what the model work is what? Just predict the next token, right? Based on a one they was trained, right? For us, we start a different way, right? If you question me something, the way I answer, I logically structure my answer and then I talk, right? Well, maybe that way work, I don't know. Maybe just predict the next token that we will use the most and then come out, maybe. But not what the so-called intelligence that the model do right now, right? So they have many more problems, or even this one. the same idea. So then the research out there, a lot of people work on hallucination and try to understand why hallucination happen. That also they make up the story, or we just said the research paper that lists you the title had nothing to do with no paper there, or the author never co-author together. So that kind of hallucination. So how generate, right? Many different things. So let me skip our example here. And but this is very good example to come out too. Just come out in 2025 in May, so a couple of months ago. So this model you guys use a lot for coding, right? Right, the cloudy. So Anthropic new AI model show ability to deceive and blackmail. So they start testing the model, and then they said that they're able to increase willing to evade the safe law, or even part attempt to steal corporate secret in fictional test scenario. And also the blackmail one of the employee who shared the story of he having an affair, because sometimes we'll talk out there and share information. So there is many things that show that the model is quite intelligent, but there's a lot of examples showing that the model is not there yet. Mm-hmm. All right. So my key point here that you cannot just developing the applied machine learning without truly understand the math, statistics, the explanation, right? It looks like what you do biotech without understanding the biology, or you build the building without explanation. So what I'm trying to say that we need to understand how the model works, how it succeed or fail, and is that robust and trustworthy or not. I think that's important. I believe that we live in very historical time right now, right? I think many exciting things been happening. The internet came out, so very excited at that moment. I think this is really, we got to go through a lot, right? For the next 50 years, what happened, we don't know. A lot of jobs will be vanished too. And then, of course, when job vanished, a new job will come out, right? So don't worry, you guys still have job. Now, for example, when let's say when the time came out, like we don't need the farmer who what they really say that in the field we use the buffalo and on the land, and then later on we have I forgot the English name to call the machine that it beat the land for you, the machine doing that evolution, right? Then that kind of job is gone because the farmer lose a job. But when new job come out, if you have that machine, you need the mechanical people to fix the machine. So the same thing for this. If this truly developed to something that we use and apply everywhere, a lot of jobs gone, like the secretary who summarize document no need anymore, right? But new kind of job coming out. Like when a couple years ago, new job came out already, the prompt engineer. You got a lot of really hard for that, but now that job is about to die too. Because the LLM suggests the prompt for you even. But you don't really know how to prompt. They ask you, do you want me to do this? Yeah. So things evolving very fast with this. All right. So what I mean by the foundation here. So I want to talk two things. Trustworthy AI, I work on many different perspectives. Basically, today I just to talk about how to do explanation because you want to see how it works. And
the word you were looking for was cloud. Right? Cloud.
Yeah. Thank you. So thank you for the explanation and what it can exploit. So I'll give you the overview of this a little bit. So one of the direction I work for many years, I work on this topic since 2016 up until now. Now you've been hearing this a lot. But in 2016, it's very rare paper, but now there's too many papers on explainable AI. Okay. So what does mean explainable AI? So explainable AI that you try to explain how the model works, right? Like when you put the image, I think I had a slide on this. Yeah. So originally you have like this. So this is a black box AI, right? So if you after you train the model, you put the image in, and then it will do classification, let's say, and it said this is a cat, 93%. Not this. Don't tell you why. How the model make that decision. But if you want to explain what relevant feature in that image make the model thinking that is a cat, for example, then you hope that somehow you would explain AI. After prediction, it gives you some type explanation. For example, the model thinks this is a cat because it has fur, whisker, and claw, while the tiger had that too. But it had this feature, for example. So what somehow explanation may be highlighted, for example, because of this and because of that, highlight some picture or some region in the image to say why the machine makes such a classification or makes a prediction, how it works. So that's called explain AI, explain the relevant feature. Okay. Another type of explain AI is explain the relevant neutron. So it may not be too high. Look at the input. Tell what's important in that input, make you make a decision, right? So for example, when the doctor diagnoses you, for example, you have fever, you're sneezing, and or because you have fever, some more than likely you have flu. So it may look at the symptom, it may the input itself. Another kind of explanation that you want to look deep into each layer of the DNA and try to figure out what neutron that activate the most, how it works. Or the circuit, if you look at the foundation model, it has a lot of different types of circuit, extension layer, and so on. Then you not like the whole foundation model will be activated to work for one of your block, right? So what's in there? They call neutron mechanism that responsible for that prediction or for that task. Okay. So that is two different explainer AI that we have out there. So it's very important. If for maybe for some certain thing you don't need, but especially in healthcare, it's very important. So last year I remember I go to National Center of Medicine, and they had a debate. They said that okay, so FDA approved some machine AI model out there for the hospital to use. Now the question here is that if the doctor use the model and misdiagnose, who is responsible? In the old time, doctor the one who's responsible. But now if I use AI, is that the guy, the software engineer developed that model and deploy, or me, the doctor who make a final decision and diagnose, right? So they debate a lot. Who had the what I'm trying to tell you that if this model when you deploy at the hospital, give the explanation, at least it helps the doctor to understand, maybe this patient had cancer because of this region, for example, or this feature, or because of this functional group or something like that. And at least the doctor had the knowledge, right? Domain knowledge. They said, oh, I don't think so. It had nothing to do with this. And this is forget about this machine. Let me I do my own decision. Or if the explanation makes sense, it helps the doctor to be with further. So that's why I said in some certain application domain, the XAI is really important. Well, in some domain you don't care. So let's say that. How many of you know how the microwave works? Inside, out. You don't care. You put the food in, hit the button, 1 minute, it warm it up. Done. It doesn't done, call someone else, come and fix. You don't need it, and you still use it. You trust, right? You drive the car, you just go in, you know how to drive on it, you don't care how it works inside, right? That is from mechanical people. So, but why you trust and you use? Then why I'm standing here and asking you that when you use a deep learning model, you want explanation. So what do you think? When you use the first, you don't need explanation why it can cold to care, it's cold, right? When you do microwave, it's hot. Warm your food, there is enough. Then no one care about explain how the microwave works for you.
No, you were comparing apple and orange. You cannot compare the two cases like that because the deep learning model, there is a probabilistic model. A probabilistic model is just probability. It doesn't mean that it's going to be correct 100% of the time. It's not deterministic. So,
yeah.
So in that case, because of this probability, you want to know, how certain, the outcome it is. So
But many things out there have uncertainty. No one produce something say 100% work, right? Right? Yeah. But in here, the same thing. I want to say that when you, I do example of microwave. It's just, I did not give you an example of something in hospital, right? So some critical application domain. Some domain really you don't need to know how it works, right? Like each summarization, the document, if a lawyer need your tool, the AI tool to summarize a document, he doesn't care how it's summarized as long as it's summarized, right? As example, as a doctor, if you use the model to help them to that, most they really need to know because it's a critical application domain. So that's why the XIIQ survived until today, right? And when the model get bigger and bigger, then we will even question more about explainer AI. So I mentioned two tabs, right? Explain the relevant neutron inside of the model, explain the relevant feature, it means just explain the input itself. So when you talk about explanation, it's also that type of explanation. You need to know what to explain. We mentioned two type explanation, how to explain so that the user understand it, right? And how to verify. It means that you have to have a way to verify that the explanation you explain is faithful. Is that what happened, right? And then what if your explanation gets exploited? Because the more you explain, the more information you release. And the same thing in daily life, right? When you explain something, of course, your partner, for example, want to have a way to verify, either try to believe you or try to verify your explanation is faithful, right? And the more she doesn't trust you, she questions your explanation, she questions your explanation, eventually she figures out the whole, right? It's a fact. Right? So the same thing here, they can exploit your explanation. So when you do explainable AI, you should be able to express all these four topics, all these four questions. I'm going to highlight my work only. So one tab, if we explanation, one tab out there, we will do explanation of that. They took the picture in the image, they took figure, they took all the picture here until the decision of the model change. Like from a delete the cat, you will took delete, but eventually become the dog example. Then you know the one you just took the relevant feature to the model, right? Because it changed the decision. So that is one way. So there is many multiplication, but we have paper. We show that the took orthogonal to the manifold direction will be the best way to the truth because you can preserve the data, the correctness of the model, and you're able to highlight the importance of the feature the most. We also show that in some application, in some model, we cannot explain. What we mean by that, if we have two different input, we have the same output out, we cannot differentiate. So no matter what you took, you still cannot differentiate. So in some model, we cannot explain. So in that case, we need to build the model interdependent by itself rather than explain. So explain AI doesn't work for our application domain. So the early way, everybody focus on explain the input, the feature, the relevant feature. And then later on, we're thinking, why don't we explain inside the model? So this is before foundation model came out. So from the inception of V3 of Google, if we put two different images in, then we go fish, right? This is one single goldfish. This is a school of goldfish. And then the prediction still say goldfish, right? The classification is still correct. But we question, will the model see things differently inside or not? Like human being, when you look at a room of one person and a room for people, you think differently or not, right? So that's why we want to explain inside. I will show a little bit more detail for this work. And then when foundation model come out, too many things, too many model, the layer becomes so good. And we question, if somebody question me the arbitrary neutron in the model, for example, can we identify the functionality of this neutron or not? So that's why we do the new concept here. And then we do the hierarchical tree, how the model looks from this layer to the next layer to the next layer, and all the way to the up. So we move the whole hierarchical concept of that. So the whole thing that we try to explain how the model works. And this book is a chart with here about if the explanation gets exploited and get do the backward attack, how we're able to do the explanation so that we can kind of protect the backward attack. So this was written here for that work. So and maybe more that I was looking recently, but I did not upload the slide. So that's the landscape of the SBIR. Maybe I will talk a little bit of this one, I think. And maybe here, I don't know, let me skip the rest. So this one, I just want to highlight the model only. It's the model like this. So when you train the model, right, then we formulate this information theory. We try to find what is look at all the activation neutron of the training sample in order to figure out the most critical neutron that being activated through all the hard sample, right? So then when we examine the new one, we can look at the activation of critical neutron and learning which one belongs to what. What I mean here, that for example, we do this. Just this is picture only. We set up with many layers. Okay, I just draw it just for the concept only. So we have goldfish. We know, oh, great. What the pattern, how the neutron activated inside, what is critical neutron for this based on the activation layer. So then later on, we can see that if it's just one goldfish, the pattern that they activate inside can be closer together in one cluster. And then for the school of fish, the way they activate and the critical path activated inside the layer after layer is differently. So then for the next English, if it's school of fish, you know for sure it had to be in this cluster. So we can say that the way they activate inside the model is different. So that's the idea. The detail, all the math and how to formulate all this is in the papers. I'm going to skip it here. But I want to say that because I want to look back into this one. So remember the checkmarks. 110 to 1 CNN layer that deployed to another habitual and then completely fail. So we use our new set. We run through that, we explain this, and here the heat map explanation. Right? And you see the red, it means where the model focus to read. Right? So where do you see the read? The outline of the X-ray had nothing to do with the lung itself inside. Nothing to do with the lung inside. Interesting, isn't it? So that how so the distribution that we look into it, we know that the model, because you know the CNN optimize one function, right? So with the least cost as possible, most effectively. So shortcut learning will form. We do have shortcut learning too, right? I remember, I must remember in my philosophy courses when I took in undergraduate, that teacher, that professor, he very serious. Quiz every single week. He had quiz 10 questions every single week. And I think he doesn't have the Scantron. So he do multiple choice, no Scantron. So I think he graded by himself. So he had a little trick. 1 week he do RA. 1 week he do C, or 1 week he do RB, that kind. So then he just looked and he knows. Eventually, after a few weeks, a student recognized, he had a pattern for him to grade quicker, right? Easier for him to grade it. So we look at all his 10 questions, and we know for sure one question, if we really truly believe our answer like C, then the rest of them we just do C for that week. Not a shortcut learning, and I bet you all do all kinds of shortcut learning, right? Once you join, most of communicated answers to be the correct answer, right? So it is shortcut learning because when they train the data and the technician, they play the token on it, and the token usually play outside. The token for the note, the disease. So then they synchronize together, they find the pattern. And that's a shortcut. And the pattern in that way. So that's why when they deploy to our hospital, they don't have shortcut. So it look at the token instead of looking for the lung itself. But the same thing when remember, I think MIT claimed that Amazon had a bias resume screener because majority female get rejected in the first phase when the machine do the screening. And that year, Amazon collaborated with NSF and launched the FAIR program. This I got the funding from there as well. So that's right, because of the story. However, it's also because shortcut learning, if you figure that the majority of female have low TBA or no have this work experience, eventually get rejected, right? So then eventually machine figured out, female rejected, male pass to the second round. You see, so the shortcut learning form during the training process as well. So I just want to say that. So we explain AI point why it doesn't work, what the model looks. So I just show you that it helps to understand the model better. And this one, we apply to this is very interesting part. I'm not spending here talking about a marker. She's better than me for that. What I'm trying to say here is this. So we work with the people who try to diagnose the ADs, Alzheimer's disease, using the fundus image. So this is the eyes image. So all this. So we know is that when we get the neutron, the same explainable AI that I just mentioned to you, so we're able to classify into different 1, 2, 3, 4, 5. How many clusters here? 7 of them? Yeah, 7 of them cluster, and each cluster corresponds into different level of AD. So then we recently remember I said goldfish. We still say goldfish. The different type of goldfish, different way to do activation. So when you use explain AI, run it into the model, we know that even also AD, different steps of AD, the way the model we put the AD different way. So we can cluster them into different cluster. So then just interesting we say that even using explain AI, we're able to figure out the different kind of stage of a disease. So I found that it's interesting, one of the way to do the explainable AI for that one. So here I go back to the LLM refusal. So this one is a very funny that I mentioned to you earlier. So when if we would say we want to see that why is able to bypass. Remember, I told you that when you ask about being a mom is harmful request, but you make up the story of that and then the answer. So because the way they safeguard this one, make that if you're able to bypass this one, that's the one that should refuse here. And if you bypass this one, then they just don't know, right? So that's how it works. And then we can use the explainable AI to explain its neutron. I think that I did too much of I want to talk something else. All right, so let me make it quickly here. So in here, for the model, you put the model in, and then we want to ask for my students do the experiment. I don't know exactly what neutron 37 means. Some number in that neutron model, and the question: what is functionality of neutron 37? And then they're able to explain the functionality of. But let me just skip this one. With the model, I want to sit through the exploitation a bit because I have roughly 20 minutes left. So for exploitation, the reason I want to mention is our joint work with her 2 years ago on this one that we're working on so after explanation, remember I mentioned after explanation, then if you use chat. So this one is a very early explanation that explains the top K feature of the input that the model based on to make a decision. So if we explain like that, then the adversary will know what is top feature. Then they can grab the backdoor trigger, right, and they run that path. Because one type of training out there is using the background sourcing, so they can embed it in here, right? And then it can create the problem. So that is the work. It's about the context of the work, and the work here is that how we give the explanation, and we still give a false explanation because you don't want to give the right explanation, but somewhat you safeguard and don't let the adversary know what is the top K feature. So that's the work about. I don't truly proud of that work that much. Whether you have the award, I think that's one of the work out there at very first hand identify this problem. When you explain, we look a lot at model information, or we look a lot of information that we have the adversary to grab some attack. So I think that's what makes the conference feel excited about. It creates a new direction of doing research on explain AI. All right, so let me go to further exploitation here. All right, so now this is I'm very familiar with this one because he's been working on this. Some of his students here too as well. So everybody use so there's a model for many different things, right? Code is one of the stuff, and there are many problems out there. So a lot of people use that. This one is Samsung use compare the code, right, to LM, ask for code condition, and then they can, cloud can observe the prompt and get what you need to do. All right. So many other stuff as well. And this is just last month or so, right? Really very funny. That is because functionality in the ChatGPT, they have the share button. If you guys use a lot, after you share, they said, "Do you want to share with a friend?" At the button, but somehow the whole conversation get into Google search, and then whatever you search on Google is for real. It's for real. Happen not under testing a toy model is for real. So you look information. So this it creates the privacy problem already, right? But now now even crazier like this. They said that that is one dimension of privacy that you have to worry about, right? You let the problem get leaked and you can recover your information. But then we will even talk further that future of LLM is not about OpenAI train a model and then you just use it. The future LLM is that you can through federated learning, right? So this can amplify the privacy leakage even furthermore. So I don't know if any of you know federated learning. Yeah, so I highlight a little bit. So client train the model. Okay. So the model, let's say this is centralized horizontal learning. There's three kinds: horizontal, vertical, and decentralized. So this example horizontal. So they will have the model. They send the model there to this user. The user have their own data, right? They train the model using their own data. So the data never sent to cloud, sent to anywhere. So, and then this a parameter tuning one. There's another version is called prompt tuning. Some example here, parameter tuning. So the train, and then they send a local parameter from the user to the server. The server averages out, and then say back. And this server route into the model converts. The server think that the model is good, and then they stop training the model. Okay, so we were thinking this for two purposes. One, to save the computing resources because you follow it there, right? You don't need a big giant OpenAI your supercomputer, right? So that is one way. Another one, thinking that because you never share anything to the client, to the server, you just share the hyperparameters. So you never send the raw data over. So that you can protect the privacy. Okay. So that is the new model. We think that it can save, protect the data privacy here by doing so. So we look into it and we try to say that, can we prove that it's really a better data privacy or we can break it, no matter how you defense. All right, so we try to do that one. So now I talk about the training tuning model in a little more detail because we're talking about not language model, right? So the model is a lost model. You don't tune in the whole parameter, the hyperparameter. You have some frozen frozen parameters that you're not going to train. You just tune in the parameter that the tell you part of the model only, and you send all this up. So in the philosophy, if you want to keep something secret, keep to yourself until you die to the top. As soon as you share something, you will live, right? So this, you share your parameters. So by sharing your parameter, can we attack and get the data or not? So that's the question we ask, right? Or sometimes you say, I have this story of my friend, please don't share anyone, right? And you tell the whole thing, and then 1 year for that, you have exactly the same story back to you, parameter change, right? The story is much different. It's about what you just said, right? So the same thing here. So we said that we set the parameter. It's not like we got say anything, right? So can we still get the data, get the data privacy, right? So this is the attacking vector that the server can attack. It's between the frozen and the tunable parameters that we're going to do. So I'm going to highlight it quickly because it's a lot of work, but we had a serious work saying that we can break the data privacy. So first of all, there are two types of data privacy. One is what data reconstruction attack. It means that you can destruct the whole private training data set, right? That's called data reconstruction attack. Another privacy, if we were talking about membership inference attack. So membership inference attack, you never see the training data, but you question whether a given target sample tree was part of the model training data. Okay. So then that means membership because you figure out that tree is in the data set training data set or not in training data set. So there are two tabs. So for the tab limit, I just mentioned one tab only. But for both, we prove that even for data reconstruction or memory information attack, we can break both. Even though we can apply LDP on top, we can apply encryption on top, we're still able to break it. So I will show you very quickly. So here's the threat model. So basically, the server becomes malicious, right? Remember, we had client pen and send parameter to the server. So we assume the server malicious and try to steal the data. Because when the server deployed this model, they said, oh, it's privacy. Protect your privacy because you never send me anything except the model parameters. So either anyway, the server can manipulate the parameter in their server when they deploy you to training, and for one round only, and after you train, you send it back. And when they look at the parameter you send back, they can figure out the B in the T in the data set or not in the data set. Okay, so the threat model here that the server is malicious. Server can manipulate the parameter that the model that sent to you for training. After one round, you send back the parameter only. They look at your parameters and they can figure out never see implement attack. Like this. Okay, so that's the attack scenario. So majority of course, when you develop that successful, it has to be at least 50%, right? Because you randomly guess 50% in or not in, right? All right. So in the parameter tuning in LLM, usually we have two types of attacking vector, right? The layer, one fully connected layer, another one webcam layer, attention layer, right? So usually we have fully connected layer, attention layer. So we have two types of attack here. So this was a step last year with the attack. So here, attack has no defense. We manipulate the way matrices and the bias vector to manipulate. It's just it's a math matrix multiplication only. And then when we manipulate this vector, and then when it's sent back, it's activate the value function or not, 0 or not, then we know that it's in there or not. Okay, so that's the basic intuition. I'm not going to go deep into that but that's the whole idea. So when the activation when they send back, and then we have this 0 activation become 0, then we know that the symbol is not in there. But it's greater than 0, it may be 1, right? Then we know it's in there just because we manipulate this value function for one round only. So the same thing for the attention layer. We also show that we use the whole idea that we use two attention head, couple each other, and the whole thing still the way we couple and wiring in the way so that we can still differentiate the one greater 0 or the one equal 0. If greater than 0, then we know that the symbol is there. If greater than 0, it's not. So it's in the same way, but because it's attention layer, so it works in different way. But the concept is the same thing, and the philosophy of attack is the same way. So let me want to go through a little more excited because this is so boring. Because you have the server so malicious, and also the client had no layer of attack. Give me a second. The layer had no attack, so it becomes boring. So then we're thinking like this. So we prove that if no layer of attack at all, okay, then the success rate is go to 1%. I have the experiment to show that. Yeah, it's local timing epoch, right? It's eventually convert to 1%. 100%. So this is just the math part to show that the successful rate of the attack when the server is totally malicious. All right. So let me go to a little bit excited here first, and then I will take the question. So how about what I'm talking earlier, the attack without any layer of protection, right? So we were thinking that why don't I LDP, local differential privacy, my data first, and then I train. So after you figure it out, you may not be able to go back and infer the data, the memory information attack. So LDP is one dimension, right? Or can I DP my gradient, right? Right here, the local parameter update. Can I DP it first? That is maybe harder for you to detect. So the whole field out there don't want to repeat the gradient because it makes the model become very bad when training. So the whole field go with LDP the data. So hopefully that is hard to go back and infer. So we want to show that even with LDP the data. So many of you who are working on the defense of privacy, so you know this definition, right? So that when the epsilon small, it means that you add a lot of noise. But remember that we train the data for machine learning. So it means that at the end of the day, when you protect the data, is one thing, but at the end of the day, we will want the utility, the precision level, the accuracy level has to be high enough, at least 90%. You don't want to work with models so that 80% correct, right? So 90%. So you can imagine that if you add a lot of noise, it becomes so noisy that you protect your data privacy, but the model training become very hard, right? So you need to find the balance, how much noise you can add, that the utility is still high enough, and you still can somewhat protect the data privacy. And that is exactly where gap we come into. We said that you add a lot of noise, your model doesn't work. If you add a lot less noise to make your model work, I come in and I break your data privacy. So we did not break the theorem of data privacy. We that proven no one break it, but we just found a gap between them. As long as the LDP mechanism out there still not strong enough to make sure that we can add a lot of noise, we still train a good model. Then we still can come in. Okay, yes.
I'm just wondering what is a good range for the asylum?
I had the experiment. Yep, I had experiment to show the good range there. So this just came out a couple of months ago for ICML 2025. So we theoretically, we proved that the success rate still very good. So this is LDP for fully connected, actually fully connected layer, still greater than 1 minus that function. So I don't want to explain the function because if I want to talk like this, I will talk the whole proof with you. But I just want to show this because that exactly that majority audience question, right? They want to see the experiment, right? They don't care the proof. I know that reviewer don't even read my proof at all. So here, you ask me the range. So we plot here the model accuracy. Okay, so the black line is model accuracy. So when privacy is 6, right? Epsilon is 4, it's around 80%, right? Go to 6, it's 90%. And about 6, it go up, right? So you add more, less noise, right? Then it go up. So, and you see that the success rate also after this number it jump up. You see? So if you want sometime between 6 here or the model 90%, the success rate also jump up. You see that? And the blue one here is just a lower bound of this here. This is just this function, that's the lower bound of this. But the blue part here, the cap part, and then it really hit to 100%. So when epsilon go to 6, it jump here right away. Of course, when epsilon so small here, then we cannot do anything either because not guaranteed by theorem, the theorem of DP, right? We cannot do anything either. But the model doesn't work either. The model on the accuracy level 50%. Who won this model, right? You see, so we don't break it either. So that's why I want to make sure to make my point clear. We did not break the privacy, the defense of privacy theory. Okay, we did not break it, but because it's applied in the machine learning domain where we cannot add a lot of noise to make sure the model train is good. So that way that we can exploit that. All right. So now you see many different stories, right? You see how good the model is, how bad the model is. You see explanation, but not all model we can explain. You see the data privacy have too many problems. And I think the next way we will really care about privacy. I'm going to talk a little more on that because he had another excited model that I did not talk about. So a couple of days ago, I think in August 13, 2025, I think CNN interviewed Hinton and asked him about, so what next for all this AI? We were talking all time, dangerous enough to become more intelligent than us and all kind of problems. So what he thinking like this? He also had the degree in psychology, by the way. So he mentioned that we need to build a model that had the maternal instinct, because no parent want to do the harm thing for their own children. So can we embed that after when we do the model, then it cannot outperform, like it goes back to harm us. That's what he thinks. All right. Another direction, we will say that all the model we have out there is agentic AI. All the model we do right now, agentic AI. Should we do a scientific AI to co-control the agentic AI? Scientific AI that learn and study things in the way that we do, have the multi-objective function that have the ethical parameters in that as well, like us, right? We go up, we wasn't trained by, we go after optimize one function, no matter what cost, right? We never do something like that. We still have a constraint that if it's ethical to do, if it's responsibility to do, or just no matter what step, everything to obtain my objective function somewhere, right? So that what, however, all the people thinking, can we coexist between AI, human, hybrid intelligence, so that between this collaboration between the machine, I Google the image, looks so nice, between the human and the robotic, right? Then we co-control and working together, collaboration. Because at any point in time, human beings are supposed to be responsible. At any point in time, we need to be responsible for our society. So by doing so, keep collaborating like this, we're able to control and develop further. So that's what very different group of people out there thinking next we should do for this kind of excited moment. And that's also conclude my talk. Thank you.
Do we have any questions?
Yeah, I know you question along the way when I talk already, but look like you have some.
Any questions, everyone?
Yes.
Why do I need to one neuron or is slowing and later? Because I can train many different models with architectures to achieve the same task.
Oh, so that yeah, so that is the AI, right? So given in AI that given specific input, given specific model he want to explain. So when I say about specific input here, that fundamental you explain the relevant feature. That you explain exactly the input type for that model. So then sometimes you say that if I want to see what function a group of neutron and a group of circuits look inside, exactly that architecture. It's not about different architecture. Because AI run on top of the model. Then that's what they're interested to know. Yeah, how it works in there. Just for debugging, for example, purposes, then you see how it works. You have any question? You just you the chance for other.
I have a lot of questions. Any questions, everyone? No questions? Are you shy?
I put too many stuff in one talk.
Hello, I have a question. Can you hear me on Zoom?
Yes, I can hear you.
Hi, this is Ling Xiao. So thanks for the great talk. So I have one question regarding like your privacy results. I saw you show like a figure about the upper bound, lower bound, and the accuracy, right? So, and I see a huge gap between the upper bound and the lower bound. So I'm just wondering, like, why you have this huge gap? Is whether it's a like upper bound loose or attack is not strong? So I just want to figure out why you have this gap here.
Yeah. So yep. So that's a very good question. So if you look at this here, this I did draw the FC, right? I did not have a slot a tension layer, right? This is fully connected layer. So the yellow is the yellow, yeah, the yellow orange so-called FC AMI. This is the attack one, right?
Yes.
Attack one. So the model accuracy is the black one, and then we simulate. I list the lower bound here. I did not list the function the upper bound here, right? But then we simulate this function to see the behavior of the wavy bound. So then this one is the upper bound that you saw, and this one is lower bound that you saw. So when epsilon is so small, it may not add a lot of noise. It's really hard for us to mathematically, because we have one function, right, to balance this one. So I agree with you. From here to here, it gets tighter, and the lower bound, upper bound get to disorder, right, to converge to one. But here, there's a gap right here from 0 to 4. So the bar in this sense, this range of epsilon is kind of loose. Yeah. So one thing. Yeah. So one thing, can you do better math? You get a better math for this one. That is tough. Yeah. So that is one that has to do. Another one, that's what we simulate to see where the math behave. Yeah. But that's a very good question.
Yeah, so I have a feeling that because we are using local DP, so basically for membership inference attack, it's better to use a central DP. And actually, there is a way to translate the local DP to the central DP, especially when the local epsilon is small. And in that case, you can somehow change your upper bound, because when the local epsilon is large, you can barely see the gap. I guess it's because there is no such like translation from local to central. And when epsilon is small, you may have a translation from local to central. You can actually reduce the epsilon in terms of the central DP. And that's just my guess. Yeah, maybe you can yeah.
Yeah, thank you for that. And another way, if you have some time, you may want to see this paper. The majority of the paper on attention layer with picture to proof. So you may want to take a look, but go back to your question. When you mention about central DP, you mean to say that DP the gradient when you send the gradient up to the server, correct?
Yeah, I just mean like
That's
if
what you meant, right?
Yeah.
So I have some slide that I think I commented out. So when you mean like this, you see the street, right? He did not see the hand, right? He not, right?
I can barely see. Yeah, I can somehow
Okay,
see.
so I talk about local DP is here, right?
Yeah.
And you talk about central DP, you mean the DP right here, right? DP the gradient and send up, right?
Yeah.
You mean this one, right? So the reason we don't go after this, because there are a couple of papers out there say that if you want to repeat this one, send up, the model becomes useless because it's really hard to get a good model. So there are a couple of papers talking about that only. Already before we will do that here, DP the data, the local DP. The first wave, we will try to do server protection with DP the gradient up here. But then some papers study say that no matter what DP mechanism out there, they cannot train a good model. So that's why the research sit into the local DP. So that's why when I started theoretically prove that, I said, there's no reason to go after this anymore. Let's go after this to see if we can still theoretically there. Yeah, instead of just a testing experiment that we can break the data privacy, but can we theoretically doubt it? That's the reason why we go down to this level.
I see. So your attack is happens for the global model or for the local model, your attack.
So the attack here, that the scenario that the server itself is malicious, they can do whatever they want.
I see. Yeah. But when you perform the
we cover the data down here, so put the local down here.
I see. Okay.
Thank you.
Thank you. Yeah.
So I think this is right. Thank you very much for your attendance today.
Thank you very much.
Thank you.
I can go and just feel free to use your LLM, no problem.
I release the secure LLM later. Very soon.
I will have some people on it, so I think I'll cover you.